Okay, so this is quiz 5C, and what we want to do is we want to find this current I and this current V. Okay, so again, there's lots of ways that we might do it, but to find this current I, since we know this current's 3.5 amps, we could find how much splits, down in this direction. So let's call this IA, and then we would find, how much splits from that point. We'd find, how much splits in these directions. So we could find I, and then we could find this IB, and then by Ohm's law find V. Okay, so that's maybe a strategy that we could use. So to find IA, we're going to have to find the total equivalent resistance, right here. So we need to find the total equivalent resistance. So let's just think about that for a minute. So if we have 50 ohms, and it gets split down to 30 ohms, 20 ohms, 50 ohms, and then back to 34 ohms. 34 ohms. So we want to find the equivalent resistance between these 2 points. All right, so we see that in this case, these two are in series. So this is equivalent to a 50 ohm resistor, and then a 30 ohm resistor, and a 34 ohm resistor, and then these two resistances out here are in series. So 50 plus 20 would be 70 ohms, and then that's equivalent to 50 ohm, and then the 30 and 70 are in parallel, and so this would be 30 in parallel with 70, which is equal to, so if I do 30 times 70 divided by 100, 30 plus 70, I get 21 ohms. And now we see that all three of these are in series. So this is equivalent to, let's see, 50, 71, 105, 105 ohms. Is that right? 55. Okay. Yeah, that looks right to me. Okay, so the equivalent resistance then is 50. The equivalent resistance, looking from this point to that point, is going to be 105 ohms. So now we can do a current divider. So the current divider says that to find IA. So we say that IA then is going to be this resistance, 42, divided by the 42 plus 105, all times, this current that's coming in. So the 3.5 amps gets divided in that way. So if I do, let's see, 42 divided by 42 plus 105, and all that's times 3.5, I get 1 amp. 1 amp. Okay, so we know then, coming back here to this circuit, we know that IA here is equal to 1 amp. All right, so 1 amp now is going to get divided this direction and that direction. So this is like, when we look at this is like an equivalent resistance of 70 ohms. And now now we can use current divider equations. I gets so I goes between 30 and a 70 ohm resistor. So we can write our formula down here. I is equal to, so we do the opposite, 70 divided by the 30 plus 70, And that's all going to be multiplied by this current, which is getting divided between the two. So times 1 amp. So this is going to be 70 divided by 100, which is 0.7 times 1. So this will be 0.7 amps. So that's what I is. So I here, and this is 0.7 amps. And so IB is going to be IB has to be the sum of those, so it's going to be 0.3 amps. Or in other words, I plus IB has to equal 1. So IB is 0.3 amps. So that implies now by Ohm's law that V is going to be IR, so it's going to be IB times R, or 0.3 times 50, which is equal to, so 0.3 times 50, 15. What? Is that right? 15 volts. Yeah, 15 volts. All right, so that's the answer. Those are the answers. V is going to be 15 volts, and I is 0.7 amps. Yeah, so the answer V is 15 volts, and 0.7 amps. If I multiply by 100, this is going to be 700 times 10 to the minus 3 amps, or 700 milliamps. So the M means times 10 to the minus 3. Okay, so that's the answer. 700 milliamps, 15 volts.